Hi kids, going to this question, a mass M is attached to n springs. There are n springs but only 5 are represented there that have relaxed lengths of 0. That is the important part of the question, 0 relaxed length. We have already seen 0 relaxed length before. Whenever spring is of 0 relaxed length, generally writing in vector form is going to be helpful. Previously there was some video in Newton's law somewhere. The other ends of the spring are fixed at various points. The spring constants are K1, K2 and so on. Mass sits at its equilibrium position and is then given a kick in the arbitrary direction. Describe the resulting motion. Again, ignore gravity, although you actually need not to. So, let me say right now it is in equilibrium position. Let me say this vector is R1 bar, this vector is R2 bar, R3 bar, R4 bar, R5 bar, and there is mg. Now, what is the force by this spring? This spring will be pulling it in this direction, so it will be minus K1 R1 bar, minus K2 R2 bar, minus K3 R3 bar. So, minus K1 R1 bar, minus K2 R2 bar, K3 R3 bar and so on, plus gravity. That should be equals to 0 under equilibrium situation. From here, if you displace it by any amount x in any direction, all this need not be in the same plane. They are not in the same plane also. If you disturb it by amount x, then what is the net expansion of this spring? That is R1 bar plus x bar. That is the new length, right? New length is nothing but total expansion of the spring. Now, new length is how much? R1 bar plus x bar. New length is R1 bar plus x bar. So, force will be in which direction? Minus R1 bar, minus of R1 bar plus x bar. This is the equilibrium position. Now, what is the net force? Net force is weight is there, apart from weight, spring force. Now, the spring force is going to become K1 into R1 bar plus x bar, K2 into R2 bar plus, I mean with a minus sign, minus K1 into R1 bar plus x bar is the spring force, first spring force, minus K2 into R2 bar plus x bar is the second spring force and so on. Now, when you expand it, you will be getting 3 terms. Now, these 2 terms will be getting cancelled, which we have already seen. Those 2 are equal in magnitude thing, right? Now, net force is going to, x bar is same for everything. So, this one will turn out to be sigma into k, sigma k, that is K1 plus K2 plus K3 and so on. If I write it as k, it looks like simple SHM form, right? Simple SHM form, then you can calculate the time period. But what is k? K is nothing but summation of all the spring constants. Now, why it turned out to be easy? Because natural length of the spring was 0. Natural length of the spring was 0. That is the major reason it turned out to be easy. Whenever the natural length of the spring is 0, it's better to write in vector form, right? Thank you.